actually had quite a lot of people asking me a bit more about the fake fire arrangement. But in simple terms, this is basically what you've got. We've got a vessel to use as a water source, and in that we actually have a little mister unit that actually provides the mist that's provided. We also have a computer fan, okay, which basically does the air flow through across the mist, which then pushes the mist over to a light source. Okay, and the light source is also in this instance a heat source, okay, which provides the up current to lift the vapor up. The globes that I used were a bank of 6 globes, okay, and I just basically put them in an arrangement like that, and they were daisy chained together so that if any one globe went out, it doesn't affect the other 5. So the water vessel I actually made up, I used a sheet of stainless steel that I actually cut the corners in and actually bent it into a trough type system. I made it up that way basically because I needed something that was actually custom made, because it had to match the limitations to the actual base that I was creating. So all of these measurements in terms of the height and the width aren't very relevant in terms of how you need to produce the effect. The only real things you need to consider is the depth of the water in relation to the top of the box and the placement of the components to actually ensure that the thing works properly. So the box that I created had an angular front section to it with a lip that actually continued out over to where the lights were placed, and the lights were placed in such a way that the lip roughly would deliver the mist to roughly the center of where the lights were. The placement of the mister was set back here. It could have been put really anywhere. There's no particular reason why it was done that way. The reason why I did it is the mister that I used actually had LED lights in it, which actually produced a rainbow sort of effect of colour, and I didn't want that colour of the lights contaminating the colour that I was actually going for in the mist, so I just set it further back in the box. The other difference is that the box actually did have a lid top, so the box became fully enclosed except for this bit at the front, where I left enough of an air gap for the mist to actually rise up through and go out over the top of the lights. To get the mist to actually travel out properly, I actually cut a hole in the lid and then mounted a computer fan to the top of that, which then produced the air to push out the mist. The other thing that I installed in the tank towards the back was a float switch. And the idea behind that is that when the water level dropped, it would actually cut off the power to the system, which would cut off the lights, the fan, and the mister unit. I did that for a couple of different reasons. One, to actually protect the electronics as far as the mister unit's concerned, so that it's not trying to bubble away with no water on it. And the other reason is when the lights go out, I have a visual reference of the fact that it needs topping up. The final thing I did to allow for the reservoir to be topped up without being completely disassembled was to just add a hose to it through the top of the base, where I could then just put a funnel on it, where I could then just top up the water whenever I needed to. So the side profile of the tank was basically that sort of idea, with the lights over here. Now, the reason why I went for a tank as large as this is because I didn't have a very big volume of depth underneath the base. If you had a larger volume, there's no reason why you couldn't change the configuration around so that you actually had a deeper water vessel with the mister on a float system so that it's at the right level to produce the mist. Having a larger tank like this, though, enabled me to actually have around about 2.5 litres of water above the level of the mister. Which translates to around about 12 hours of sort of continuous running time before the actual float switch cuts off the mechanism because the water levels drop too low. You could certainly change the configuration of the tank to do whatever sort of setup you need. The type and size of the tank isn't all that critical. The most important parts I've found to take into consideration is the gap that you actually have between your water level and the top, whatever acts as the top. That's where the mist actually generates inside before it actually comes out. You need a minimum distance of around about 1 inch or around about 2.5 centimetres if you're trying to work it out between the water level and the top of the tank to actually have enough area that it actually generates the mist that you need in the first place. Any closer than that and it just doesn't have enough room to actually nebulise the liquid, and you end up with no result whatsoever. Equally, that measurement remains about the same for the height that you need above your mister unit. So your mister units sort of look like that, and you need that round about that 1 inch to 2.5 centimetres gap between the top of the unit and the top of the water level to actually generate the mist in the first place. So those two measurements between the gap to generate the mist above the water and the gap to generate the mist below the water remain roughly the same. The lights were made out of a similar sort of box made from sheet aluminium. I just made up a box like that, and I did air holes in the bottom of the box, and then I mounted the 6 globes inside so that they have this sort of arrangement. I've only allowed enough there for 5, but you get the idea. And then I lined the inside of the box with the reflective insulating tape so that it actually reflected a little bit more light. Now, if you wanted to use an LED system, so that it wasn't using as much electricity or it wasn't producing as much heat, you would do this basically the same idea. The other thing I should mention that these lights are a yellow light. They're not a white light, and they're not a red light. I find that the actual the yellow was the one that actually produced the most amount of realistic look to the flame in comparison to, you know, putting it next to what a real flame looks like. The density or the thickness of the mist is really what determines the variation in the colour as it passes over the top of the lights. So if you're going to do this system with an LED system, there's no reason why you couldn't. Again, you'd need to have yellow lights, not white. The difference is that you might need to have an updraft fan as well. So the mist that's produced by the unit is quite cool. It's not like steam at all, so there's no actual convection in it. So the mist will have a tendency to linger over the surface of the water and sort of just hang around. You've got to remember these are made generally as a pond feature where the mist sort of hovers over the top of the water. So if you need it to sort of get moving through, that's what the computer fan was at the back. You may need to get a similar sort of setup if you're using LEDs instead of the halogen globes. The setup for the electrical system was pretty straightforward. I actually had 3 different systems, 2 being a low voltage system and the other one being a high voltage system. And depending where you are in the world, that'll either be 240 volts or 110. The other 2 were a 12 volt system and a 24 volt system. The 24 volt system ran the mister unit, and the 12 volt system ran the bank of lights arrangement. The 240 volt obviously provided power to those 2 systems, but it was also used in the electric lift system, which was the power jack arrangement that are designed to actually lift the full weight of the Terminator and have it set at different heights. So obviously it's not a great idea when you're dealing with water and electricity to actually be having a high voltage anywhere near the water. So the way I basically had it set up is when I had the box arrangement set up for the holding of the liquid, the float that I had in there was obviously triggered by the level of the liquid, but it was hooked back to a little relay box, and that was a 240 volt relay. And the idea behind that is that when the water level dropped, the float dropped to a certain level and triggered the relay, which actually cut the power altogether and cut out the light system and the float. Now the problem behind that is that you can't run 240 volts directly to one of these switches for 2 reasons. Number 1, it's floating in water, not a good idea, and number 2 is that the actual internal mechanism of this won't handle the voltage of the 240 volt. So the 24 volt system was actually piggybacked off the relay switch so that and also powered the actual mister unit at the same time. So even though it was the mister unit that triggered the switch then triggers the relay, which cuts off the 240 volt, which in turn turns everything off. And then quite simply, to re-energize the system, you simply just have to bring the water level back up to a correct level, which brings the switch back in line, and the system re-initiates. If you can imagine looking down on the unit itself, I've got a sort of diamond sort of configuration thing going on with the box itself. The fire unit is set at the back. That's where the light arrangements are. The water reservoir sits in front of that with a little computer fan and that sort of thing there. And then the electrical system is behind the light arrangement, okay, and to the side. This one basically has connections to the float and to the mister unit, and then splits to actually go through the 240 volt system, which, as I said, daisy chains across those ones to actually power those lights. I'll include a far more detailed drawing in the bonus material section, so just click on that if you want to go and see it. The other part of the electrical system is in the front here. I did 2 switches that went back to the main electrical system. One was to turn everything off, and the second switch was just to turn the mister unit or the mister assembly turned off. What you might remember with this setup is that I have a light ring that goes around the outside of the setup, and I set that one up so that it was wired separately to the mister unit, so that I could still have that outer ring operational, even if I wasn't operating the fake fire aspect of it.